Welcome to Study Loop.
This question asks us to look at the energy involved with making a phase change. In other words, the enthalpy of vaporization, the phase change from liquid to gaseous state. And the question is, why does it require more energy to vaporize water starting at room temperature down here versus when it's at its boiling point up here? And if we kind of look at the heating curve here, it sort of speaks for itself. Um, if the amount of energy required to vaporize a sample starting at room temperature, we really can't vaporize it until it reaches the boiling point temperature. So we have to put energy into the process just to get it up to the boiling point temperature if it starts at something below that. If we kind of look at this in terms of an equation, um, the equation for putting heat into making a temperature change is dependent on the specific heat of the substance, C, the temperature change, and the amount of substance you have, or the mass of the substance. So this equation and the amount of heat um, relative to that substance would have to be put into water just to raise its temperature up to the boiling point. We have to put that amount of energy into the system before we can boil it. However, if water's already at its boiling temperature, all we need to do is undergo that phase change, this sort of area of the plateau. That requires just putting into the process the enthalpy of vaporization and the number of moles of water that we have. That's the total energy that then will go into vaporizing a certain quantity of water. So bottom line is, if water's already at its boiling point temperature, we just need to put the energy into making that phase transition from liquid to gas. If it's at a lower temperature, we need to first increase the temperature up to the boiling point and put some additional energy into the process. And then once we reach that temperature, we can go through the phase transition process at that point.